El Nino is synonymous with the picture of the red-hot wave crossing the Pacific Ocean to the coast of Peru and up along the Pacific coast. El Nino was named after the Christ child because people first noticed that it occurred around Christmas time. El Nino refers to the irregular warming of the sea surface temperatures from the coast of Peru up through the eastern Pacific coast. This causes a disruption of the ocean atmosphere system in the tropical Pacific, having important consequences for weather around the world. While the phenomenon is not totally predictable, on average it occurs about every 4 years or so and lasts for 18 months. Evidence of the phenomenon of El Nino can be traced as far back as 3000 BC, where researchers have looked at coral specimens that old and have seen chemical signs of warmer sea temperatures and increased rainfall. Around 1500 AD, in Peru, fishermen discovered that the periodic warm weathers held down their anchovy catch, and farmers noticed that the warm waters led to increased rainfall, transforming normally barren areas into fertile farmland. Between 1700 and 1900, European sailors made sporadic attempts at documenting the phenomenon. Scientists became interested in identifying the cause of El Nino. In 1891, Dr. Luis Carranza, a Peruvian geographer, published an article associating El Nino with the unusual rain patterns. In 1923, a British scientist, Sir Gilbert Walker, discovered that when air pressure is high in the Pacific, it is low in the Indian Ocean from Africa to Australia, and vice versa. He named this phenomenon the Southern Oscillation. Thus, scientists since refer to El Nino as El Nino Southern Oscillation, or ENSO. In 1969, just a mere 42 years ago, a professor at the University of California at Los Angeles, Professor Jacob Berkens, published the first scientific description of how El Nino works. Data from the National Oceanic and Atmospheric Administration, or NOAA, shows the warm temperatures in the Pacific Ocean bordering Peru and the eastern Pacific coast following along the equator, showing the effects of El Nino. In normal conditions, the prevalent surface winds across the equatorial Pacific Ocean are easterly trade winds blowing from California and Peru to the western Pacific. These winds pile up warm surface water in the western Pacific. This drags warm surface water away from the coast of Peru and causes colder, deep ocean water to come up to the surface, called upwelling. Upwelling causes the thermocline, the zone at the top part of the ocean in which temperature decreases rapidly with depth, to be much shallower in the eastern Pacific than in the western Pacific. Trade winds in the equatorial upwelling maintain warm sea surface temperatures at the western equatorial Pacific and cold surface temperatures in the east. When trade winds weaken, the equatorial upwelling decreases. The thermal incline gets deeper. The ocean surface along the coast of South America becomes warmer, and trade winds weaken even more. This in turn causes surface waters in the eastern Pacific to become even warmer. This represents the onset of El Nino. Rain follows the warm weather eastward, causing droughts in Indonesia and Australia, and severe rains in the coastal deserts of Ecuador and Peru. During El Nino, the trade winds relax in the central and western Pacific, leading to a depression in the thermocline in the eastern Pacific and an elevation of the thermal incline in the west. In La Nina conditions, the reverse happens. The thermal incline increases in the eastern Pacific and decreases in the western Pacific, like a seesaw action. Current forecasts that were published in the Pacific ENSO update, the first quarter of 2011, said that the La Nina is currently nearing its peak, and therefore scientists believe that we will now be entering a normal cycle before yet another El Nino period starts in 2013. Seawater temperatures were graphed from 1965 to 2010. The red tips of the spikes in temperature changes demonstrate temperature changes of 0.5 or more degrees Celsius increase in temperature, which shows an El Nino condition, while the blue tips show changes of more than 0.5 degrees or more decrease in seawater temperatures, which shows a La Niña condition, while the white areas show a less than 0.5 degrees Celsius, which equals normal conditions. In non-El Nino years, upwelling of deep, cold ocean water brings up nutrients that lie near the bottom of the ocean. Fish living in the upper waters feed on the plankton that are dependent on these nutrients. Kelp forests also depend on cool, nutrient-rich water for survival and growth. In non-El Nino periods, the upwelling of cold water is decreased. When this happens, fish either die or migrate into areas where they'll find more to eat. With the fish gone, seabirds that depend on them may die or go elsewhere. Kelp forests are often destroyed by storms and ocean swells. El Niño phenomena dramatically affects the weather throughout the world. While we see flooding in the United States, drought conditions exist in Australia and other portions of the western Pacific Ocean. Those observing ocean systems are part of the Tropical Ocean Global Atmosphere Program known as TOGA. TOGA consists of scientific research ships and buoys which form the operational ENSO observing system. Buoys include moored buoys, drifting buoys, and expandable buoys. All these provide the data on upper ocean and sea surface temperatures. This information is then sent to satellites, and then from satellites to researchers around the world.